back of yesterday's homework. Any questions on any of those? You have questions? Okay. Which one? This one here? It says that. Ooh, thank you. I didn't notice that. Edward, when he realized he didn't have it, he began running back towards home. Sorry about that. Good catch.
Wait, I didn't realize I was
And so then it should go like this. Nice ways. Okay. On to notes for today. So what we're going to do is it's going to be a lot of what we did already, but just talking more about it. So multiple representations. So a function is a relation where we're going to talk about it as input, and input has exactly one output. There are many ways to represent functions. Graphs, tables, mappings, ordered pairs, and then, did you guys not get one? Thank you for saying something. Okay, so how do we know if a relation is a function or not a function? So for a graph, what do we do to check whether something is a function or not a function? Vertical line test. So use the vertical line test. Show me with your hand what a vertical line looks like. That's right, straight line up and down. So if what line? What do we put here? Vertical line passes through the graph more than once, it is not a function. So we're going to do the first two here. So we'll do the first one on the top left. So what do you think about that? Function or not a function? Probably, or it is, yes. So on your homework, you're going to have to do a short explanation for each one. So what would be our short explanation for that? So will any vertical line pass through it more than once? No. So no vertical line passes through the graph more than once. Okay, what about the second one? It's definitely not. That's right. Why no? So for example, this vertical line would pass twice. So all it has to be is one. So a vertical line passes through twice. Okay, so we'll stop there because I think that's pretty clear. We don't need to do the other two examples as well. Yeah, just a short explanation. So on the table one, so what do we want to check on a table? The x's, that's right. We want to check the x's. If the blank in the tables are repeated, if the x's in the table are repeated, it is not a function. So So let's look at this example on the top left. What do you think? Function or not a function? No, that's right. Four has 2 y's. So 4 has 11 and 4 has 5. So there's more than one explanation that you can have. I just went real specific there. I wanted to do specific. So what about the table on the top right? What do you think about this one? That's a yes. So again, no repeated x's. I think that's pretty self-explanatory for the tables. So let's move on to the next ones. Let's do a mapping. The mapping you're probably a little less familiar with. If an input maps to more than one output, it is not a function. So on this first one, do we have any input that maps to more than one output? No. We don't. The 3 maps to one input 3. The 12 maps to one input 4. The 19 maps to one input 2. So it is yes. Each input has one output. What about the one on the top right here, this mapping here? No, that's right. Which input has 1? So 1 has 5 and 7 as outputs. Does that make sense? So then the next one is ordered pairs. So we want to check the x's. If the blank x's of the ordered pairs are repeated, it is or it isn't a function.
That's a function for sure.
If the x's are repeated, it is or it isn't a function. It's not a function. Oh, I know what you're looking at. You're looking at the first example. Yeah. Okay. So let's look at that first example. Do we have any x's that are repeated?
No.
No. So this is yes. And the explanation could be no repeated x's. What about the second one? No. What's repeated? 5. 5 is repeated. It has both a -10 and a -3 for an output. Does that make sense? Okay, let's go to the back. The situations, which are the hardest. So situation A, the x is a weight, and y is a person. So say the weight is 120 pounds. Could there be a person, more than one person, that has a weight of 120 pounds?
Yeah.
Sure.
Yes. So is that a function or no?
No.
No. So we can say more than one person. And weigh. We can even list that specific example. If you like, I can just do all of these since the situational ones are a little harder. X is the number of binders and Y is a person in Mrs. Costello's period 5 class. So say it's one binder. Could there be more than one person that has one binder? Absolutely. So yes or no? No. And the explanation could be more than one person has one binder. Does that make sense?
Yeah, it is.
Okay, situation C, phone number. So you have a specific phone number. Will it go to a specific person?
Yeah.
Or could it go to more than one person?
It's all mine are on one person.
How could it go to more than one person?
No, it wouldn't, JJ, because everyone has their own number.
Not, sometimes not always.
Yes, it does.
Because we don't have repeated numbers.
No, we don't. Not on that.
Yeah, wait, if you lose your phone or you disconnect that, yeah, so if you have disconnected phone, then you don't have that number anymore. Does that make sense? Somebody in the last class gave a scenario. So we're going to ignore home phone numbers. So for example, in this classroom, if we were talking about home phone numbers, we have two students who would have the same home phone number. We have our two twins.
Oh, yeah.
So we're going to ignore the home phone number. We'll say we'll ignore it. Does that make sense? So you don't have a home phone number, so we don't even have to do that because most people don't have home phone numbers. Most people just have their cell phone. Okay, so we're going to say yes. So each person so a phone number goes to a specific person. Okay, last one, a person and blood type.
Oh, yeah. You can have the same blood type. You can be the same person, right?
Correct. So we're starting with, say Shane, for example, will he have more than one blood type? Yes. So could Shane have more than one blood type?
No.
No. Each person has one blood type, one and only one blood type. There may be someone else who has that same blood type. I could have that same blood type, but I'm somebody else. So that ordered pair would be a different ordered pair. It's not a repeated X. So it is a yes. Each person has only one blood type. You have a question on that? I know this has been the hardest one because we're not going the other direction. We're not going blood type to a person. We're doing a person to blood type. So it could be Dea type O. And then we have Will.
Oh, yeah.
Could also be type O, but that still would make it a function. Doesn't matter. He's only going to have one blood type. Does that make sense? Okay, can I get somebody to pass out the